Okay, folks, so here we have a short little program that's going to divide an int in half and then print out the half. Okay, let's see, we declare our int, we divide it in half and save that as a double, and then we print it. Let's try this. Okay, 15 divided by 2 is, so we got 7.0. Alright, so let's dig into this and think about why we might have gotten 7.0 here. So 15, like if you can do the math in your head, divided by 2 should be 7.5. But for some reason we ended up getting 7.0. Now I thought that if we did this division and then saved it as a double, our answer would be a double. But the thing to remember is that what's happening here is an int divided by an int. And remember, in your previous lesson on number calculations, an int divided by an int is going to do integer division, which means that our answer is always going to be rounded down. So 15 divided by 2 rounded down is going to be 7. And so this actually evaluates to 7, and then that gets converted into a double, 7.0. So we want to think about how we might use casting to fix this. So you might be thinking, well, what if we just change this to a double over here? Would this fix the problem? Yes, definitely. This is a possible solution. The problem with this is that this is a very simplified example. And there are lots of programs where you might need to keep this information as an int, maybe because it's being used as, a variable for some other part of the program, or it's a count of something. So we don't want to necessarily change the data type of our variable. Instead, we want to do something during this calculation here so that for the moment we can consider our int a double. Okay, so this is where we're going to be using casting. I can do a cast here, and I can use parentheses to cast this whole thing as a double. Let's try running that code. So again, we still have the same problem, right? And if you think about it, it's because, again, we've done our parenthetical division, 15 divided by 2, and then we've tried to cast that int division, which became 7, down to a double again. So we haven't really addressed the problem, which is that we want to be doing double division. Okay? So instead of trying to convert the entire thing to a double after the operation, what if we just cast the x as a double and then did our division by 2? If we try running this code, this will give us our 7.5, because a double divided by an int is going to automatically turn that int into a double. Now, here's another interesting thing that you could have tried. What if instead of dividing by 2, we divided by 2.0? This also works. So this is one of those examples where, again, if you're dividing and doing a mathematical operation that combines doubles and ints, there's going to be a implicit conversion where your ints start acting like doubles. Okay, so let's try this the other direction, where we are going to use a double first, and we want to cast it to an int to get, we'll just call this rounded half. Alright, so we have our double x 15.0, and if we do x divided by 2.0, we then save that as our rounded half. So here, remember, we have an error message because Java does not like, there's another error here that I need to name my variable, but Java doesn't like, here it says lossy conversion, if we try to automatically take a double and save it into an int. Okay, so in order to be allowed to do this, we need to cast our answer to an int. Now I hope that when you saw me doing that, you were screaming at the video saying, no, you need more parentheses, because what I did here was I just cast the int x, and I didn't cast the whole division, and so again, an int divided by a double, this whole thing became a double. Our conversion to an int has to take into account the entire division problem, and we'll use parentheses to do that, and so then if we try running our code, we get 7. But is 7 the rounded half? 0.5, 7.5 should have rounded up. See, so this is an example of truncation. Remember, when we cast to an int, our double, instead of getting rounded, actually gets truncated. We just lose the entire decimal portion. So we do have a solution for rounding our numbers, and I'm going to show you that in the next video.